All right, ladies and gentlemen, agents of the SSI, we're going to be going and balancing the chemical equations from the reactions that you've been working with over the course of the last several days. You should have received a balancing chemical equations worksheet. This worksheet is going to allow us to provide information to Commissioner Gladfelder that the chemical reactions that we are looking at are controlled and understood. A couple quick reminders here. The 4 reactions you're going to be looking at, or chemical equations, are the 4 reactions that you have used throughout the course of the training here. Baking soda and vinegar, calcium chloride and baking soda. We got the aluminum and the copper 2 sulfate, and the effervescent tablet and water. So we want to make sure we understand what we're looking at here as we go. Just a quick reminder that the materials that we start with to the left of the arrow are going to be the reactants. To the right of the arrow are going to be the products. To figure out if a chemical equation is balanced, you must make sure you have the same number of each atom on both sides of the chemical reaction, both within the reactants and the products. So let's do this together here. Na, you're going to notice there is 1. We add up the total number of H's. There's an H here in the baking soda. A total of 4 H's in the vinegar. That gives us 5 total H's for the reactant side. We're going to see the oxygen, 3 based off the subscript, 2 here based off the subscript, total of 5 in the reactant side, and the number of carbons. 2 carbons here based off the subscript, 1 carbon there. That is a total of 3. Your job is to add up the total number of each atom on the product side. If they're equal to one another, you have a balanced equation. If they're not equal to one another, you have an unbalanced equation. So you're circling yes or no. Here we're going to take a look at the next one. Let's start through the process again, looking at we have an Na present on the products. We look for the total number of H's. You'll see 2 H's present. The total number of O's, there's 1 O, plus 2 O's is 3 O's, plus a total of 3 more, 6 O's total. How many calciums? You're going to see there 1 calcium. How many chlorines do we see? We see 1 chlorine. And the number of carbons, 1 carbon, 2 carbons. Again, to make sure that whatever you finish with, you must have at the beginning. So we take a look. 1 Na. The total number of H's is 1. The total number of O's is 3. Number of Ca's, 1. Cl's is 2. And the carbons is 1. What I recommend that we do is you find one element that is not a hydrogen or an oxygen, and you begin to balance them. So taking a look, let's pick the carbons. We take a look at the carbons. There is 1 carbon here on this side, 2 carbons on this side. How can we go about and balance those out? To do so, I recommend you always multiply the lower number by the higher number, and that's going to give you a start for the chemical equation balancing. So if you want to get this to equal 2 times 1, that means you need to change the coefficient. The coefficient being the number 2. But now when we do this, it modifies every element or every atom that's present in this molecule. So not only did it increase the carbons to 2, what did it do to the sodiums? Well, the sodiums are multiplied by 2. The hydrogens multiplied by 2. And the oxygens multiplied by 2. If we take a look, do we have everything else that is balanced? Well, when we're taking a look, the sodiums and the chlorines are different. So what can we do over this side where the lower number is to get it to equal the higher number? Well, if we take the Na, change the coefficient to a 2, how does that impact all the other atoms? So as we take a look, we can start to balance out the chemical equation. So you should be able to take a look and see how these are balanced based off of going through each of the steps to make sure the numbers in the atom inventory are correct. You have your last 2 reactions here. To take a look again, get your inventory from the products. So if we look, Cu or copper is 1, Al 2. If we take a look here, do not forget you have a subscript multiplied by another subscript for the O, which gives us 12 total O's. There is no subscript here, so we assume that is a 1. So 3 times the 1 because of the parentheses. Remember, distributive property, just like math, gives you 3 of the S's or sulfurs. You go ahead, calculate out what the inventory for the atoms in the reactants are, and then start to change coefficients if this is not balanced. You're going to see here for the effervescent tablet, the SSI has provided you with some coefficients. Are the coefficients correct? A couple reminders: if you have a coefficient in front, it multiplies times all the subscripts that would be after, and that helps give us a total. So you need to make sure you can check how many C's on both sides or on the reactant side, including both elements or molecules. How many H's, including both atoms or sets of atoms in the reactants. How many O's. Do not forget to multiply your coefficient times the subscripts that are present. Okay, so this is going to be really important. Do not forget to do so. All right. To give you a quick reminder, if we take a look here, 3 times the Na gives us 3 NAs. 3 times the H gives us 3 H's, but do not forget you do have 8 H's here, so that's 11 total H's. The number of O's, 3 times 3 is 9 O's, plus the 7 O's that are here, 16 O's. And the 3 times the carbon, and that gives you 3 carbons, plus the 6 carbons here, 9 carbons. Is this a balanced chemical equation? You need to figure out the atom inventory for the products to be able to go and do so. Good luck. Make sure you hand your paper in before you leave class. When you are done, you will get further instructions on what to move forward with.